Hi, this is Emily Sledge, and I'm here to talk with you today about when to use the calculator and when not to. Part of what I'm going to do today is temper your enthusiasm for the calculator. Many people hear that there's a calculator on the GRE, and that's great because then they don't have to do as much math. Not necessarily so. No questions on the GRE are completely calculator dependent. In other words, having the calculator won't get you any points that you wouldn't have gotten otherwise. That said, it's a good tool to have, and as we proceed today, you should have a rudimentary calculator handy. In fact, the more basic the better, because the GRE calculator built into the test is pretty basic. It doesn't even have things like, x squared button. If you want to do 38 squared, you have to type in 38 times 38. There is a square root button, however, but there's no fancy exponent buttons. You can't easily do 2 to the 5th without manually doing 2 times 2 times 2 times 2 times 2. Okay, so those are some basic limitations, but let's look at some problems to see why technically there may not be limitations, but you may still not want to use the calculator. For this drill, I'm going to give you 3 minutes to do this, so average of 1 minute per problem. Take that time, note your answers on your page. All right, some calculation problems. The very first one can be done, but there's no percent button on the GRE calculator. So for percents, you must remember how to convert a percent to a decimal. And it's pretty simple. You just shift the decimal to the left 2 places, like dividing by 100, and take the percent sign off. So that means that 37.5% can be written as 0.375. So literally that's what you type into your calculator. 0.375 times 2, divide by 3, and you get your answer of 0.25. Another way to go that might save you some calculator entry is if you recognize that 37.5 actually has a pretty simple fraction equivalent. People in the mortgage industry will probably recognize eighths of a point, as well as other industries use those increments quite a bit. So 3/8 of 2/3 is the other way to think about this. And with fractions, you can actually just cancel as much as possible on paper and actually save yourself from even having to plug into the calculator in this case. In the second one, not much can be done with quantity B. So all the actions in quantity A. And remembering that we don't have a square button, we're going to have to do this calculation in 2 steps. So the 2 steps are first figuring out what that fraction is inside those parentheses, and you get 0.4 as a result. And then to square it, you just times that with itself manually. Turns out the 2 quantities are equal in this particular case. And on QC in particular, think carefully before you start plugging in numbers. Here I think it's worth doing, but on a lot of QC questions, the exact value you get is not as important as, the relative values of the 2 quantities. If there's something that tips you off that one is going to be much greater or much less than the other, you don't necessarily have to verify that with a calculator. And there's a little bit of that kind of thinking in the bottom question. By the fact that it asks us about which is largest, it's a little bit like a comparison question. And you can save yourself some time on these. Instead of plugging in all 5 quantities into the calculator and then comparing the results, think strategically first. So notice that they're each a percent of a number. You can compare in that sense before plugging. So notice that there are 3 answer choices here that all are a smaller percent of a smaller number than we find in B. So without even calculating it, we know that A, C, and E are going to be smaller than B. They can't possibly be the largest answer. So the only 2 we need to really check in the calculator are B and D. And again, just know that you have to convert that percent to a decimal. Be especially careful with 8% in D. Notice that moving the decimal over 2 to the left leaves you with 0.08, not 0.8. Here's a second group of problems, or a single problem. For this one, I think I'll give you 45 seconds on the clock. All right, note your answer on paper. And this one, of course, it's a word problem. So before you even start typing in numbers into your calculator, you have to process what the words mean. And that means most of the action in this question is in that translation. So personally, I would do this on paper before going to a calculator. You want to be clear on, what's what. M for men, W for women if you set this up algebraically. And there's some substitution that is beneficial to do before you go to the calculator. Really, the first calculation step is down here after the substitution, subtracting 16 from 94, dividing 78 by 2, and then finally kind of verifying or calculating the number of women from the number of men. And you could even add 39 men to 55 women in the calculator as a final check to see that you get 94 people in the room as expected. So I think this is a problem where, since so much of the work is really in the setup and the calculations themselves are pretty straightforward, the calculator really doesn't buy you much in terms of an advantage. And just to be thorough here, you don't necessarily have to do this in as algebraic a way. You can take a more common sense approach here. Think about, people square dancing and imagine pairing up men and women in this room. We know there are 16 extra women who will not have a square dancing partner according to the rules of this game. So if there's 16 unpaired women, that means there's 78 people who actually do have a dance partner. And so 39 of them, or half of them, are women, and you can get to the 55 women total from that, right? 39 are paired, 16 are unpaired. There you go. And so notice that the math is very much the same. And again, the calculator is a crutch, but is not absolutely necessary. Take a look at this one. All right, so this is a true to life example. You've probably calculated averages of your own quiz scores in the past. And the calculator comes in handy for this. So 5 scores average to 52. The sum of the 5 scores is the product there, 5 times 52. 260 has to be your sum. If 6 scores would have to average to 57, then this, by similar logic, the sum of those 6 scores would be 6 times 57. Calculator definitely comes in handy there. You could certainly do that math on paper, but the calculator provides a nice check. And so what that tells us is that the 6th score must be the difference between those two sums, right? The 6th score raises the sum from 260 to 342. That's a difference of 82. I still like the idea of doing a common sense check. There's always that chance that you plug in the wrong number into a calculator and you get the wrong answer as a result. So I like to think to myself, does it make sense that the 6th score would have to be that much higher? It's 30 points higher than the rest of the score's average. In other words, that person's really screwing up the curve in this class. So 30 points higher means the sum of all their scores would be 30 points higher than if they just all averaged to 52. Does that make sense that it would move the average only 5 points? Yeah, it does, because there's 6 scores, so the sum gets divided by 6, and so that 30 points extra gets divided by 6, adding only 5 to the average. Okay, so that's just a common sense check. Take 45 seconds here. All right, so you can certainly take the sum of 1 through 11 inclusive. Remember that means to add in 1 and 11 as you sum up, as well as all the numbers in between. And if you do that in the calculator, it's a lot of button pressing, but you get to 66. And that lets you calculate the average pretty quickly, since average is sum divided by the number of terms. And it's a short jump to the difference between the sum and the average. That part you probably wouldn't even need to do in the calculator. There is a more sophisticated, maybe more common sense way if you know some properties of consecutive integers. And the main property is that the average of a set of consecutives is just the middle term. Okay, so we have 11 terms. The sixth term is the middle one because there's 5 below and 5 above. Okay, so that's number 6. And it kind of makes sense. The reason that works is that, 6 is the middle term, and there's a term below and above it that also average out to 6, right? 5 and 7 add up to 12. They average to 6. Go 1 up and 1 down again. 4 and 8 average to 6. 3 and 9 average to 6, and so on. Okay, so the middle term is magical in a set of consecutive integers, and you can exploit that. The average is basically given to you. And from there, you can calculate the sum, kind of the reverse of the math we did up here. 6 times 11 gives you the sum. Okay, so just different order of thinking through it, a little less button pushing. QC question. Take 30 seconds here. "30 seconds is not much time, but there's also not much math to do here. Even if you did the calculation manually, it's doable in 30 seconds, but certainly with a calculator, it's pretty fast. So 0.35 times 60, that's a $21 discount. There's an even faster way that involves kind of cheating off the easy quantity of 20. 20 is exactly a third of 60. Easily seen. And if you kind of remember your decimal equivalents, you know that 1/3 is 33.33%. 35 is clearly more than that. And there you go. A is greater. Another QC. Take 30 seconds. All right, again, 30 seconds, not very long, especially if you took to heart what I said about raising something to a large power, you have to actually type it in. So if you're going to do -1 to the 2002, doesn't that mean you have to do -1 times itself manually 2002 times? No, it doesn't. Obviously not. And if you started to do it, you probably saw the pattern that I'm hoping you recognized, which is that when you have a negative base and you take it to integer exponents, it alternates sign. So -1 to the first power is just -1. -1 to the second power is +1. -1 to the third power, -1 again. And back and forth, back and forth. That's what this question's really about. It's about the exponents. Even exponents in quantity A on negative bases, and we've got odd exponents in quantity B on one base that's positive and one that's negative. Okay, so the deal with the alternation is that even exponents hide the sign. So when you have an even exponent, no matter what the base is, whether it's positive or negative, you get a positive result. Okay, so each term here is 1. So quantity A is 1, or you could just think to yourself quantity A is positive. With the odd exponents on quantity B, they don't hide the sign of the base. So it's not so important to actually figure out what 7 to the third is and minus 3 to the fifth is and actually get those numbers. What's more relevant is that 7 to the third is positive and minus 3 to the fifth is negative. And as a result, quantity B is negative, some negative large number. But comparing it to A is positive, B is negative. There you go, A is positive. A is greater because it's positive. All right, take the time you need. I'll pause here briefly. All right, I didn't give you a timer on this one because I figure it's pretty fast. The main point to make here is that while there are parentheses buttons on the calculator, personally, I don't think that they are worth messing with. You would use those if you wanted to do a series of calculations and kind of save one part of it and then operate on it later. I think that's just too much hassle when you have your paper to achieve basically the same thing. And so what I mean by that is, there's that calculation in the top here, and then you divide it by some other number in the bottom, which itself has a calculation to be done. Just write those down on paper. Do it as 2 steps. So the top calculation helps if you recognize 3/4 is 0.75. You could just type that in. If not, do 3 divided by 4 and then subtract 0.11 from it. But both top and bottom give you 0.64. No calculator needed to see that divided by itself is 1. All right, take 1 minute on this question. Okay, so we've got this square kind of tacked onto a right triangle. That should get you looking for some shortcuts. And hopefully you saw one of them, which is that triangle on the left side is a 5, 12, 13 right triangle. If you didn't quite see it, you can use the calculator and Pythagorean theorem to figure it out. So squaring 12, you get 144. Add that to 25, which is the square of 5. You get a sum of 169, and then use the square root button on the calculator to get 13. And of course, if that's a square, all 4 sides have a side of 13, or a length of 13. And we can turn our attention to AC. Here's where another rule about squares comes in handy, squares and triangles. When you split a square diagonally, you get 2 45, 45, 90 triangles. And it's helpful if you remember the property of diagonals. They are always root 2 times whatever the square's side is. And again, you could arrive at that. Just square 13, get 169, add it to 169, and then take the square root of what results. Whether you do that or do square root of 2 times 13, by calculator AC is approximately 18.385. Now, having said that, it's unlikely that you would have to actually calculate that out. If this were a multiple choice question with 5 numerical answers, the length of AC would most likely be listed as 13 root 2, and you would not have to simplify it. I can think of times on QC questions, quantitative comparison, where you would actually have to calculate it out. Let's say you were comparing 13 root 2 to 16. You might want to plug that into the calculator to see, is it greater than 16 or not? All right, last problem in this segment. Take as much time as you need. I'm not going to put the timer up. I'm going to pause here for 3 seconds, during which time you should hit the pause button, work on this problem, and then come back. All right, well, welcome back, and hopefully you were able to make some sense of this question. A lot of percents going on here, and at least a couple whole numbers and 1 fraction, so lots going on. Break it down. If you're going to use the calculator, you can't plug in those percents, so you're going to have to convert all those percents to decimal equivalents. So again, you just move the decimal over 2 to the left and take the percent sign out. It's also handy if you recognize that the is in any sentence about math is like the equal sign. Is means equals. And so I've drawn that vertical line there to kind of keep that visually separated. You can deal with the left side of the sentence separately from the right side. And so literally what we've done here is converted percents to their decimal equivalent, converted the word of to multiply, right? We're multiplying those terms every time we see an of. And one other conversion was done here. What percent can be written as question mark over 100 or x over 100? And think about why. 25% could be written as 25 over 100. That's literally what we're doing, only using the word what interchangeably with x here. Okay, so now we can clean these up in the calculator. And the second line is here just to show that you can't put an x into your calculator. It's still there, pulling it off to the side. What you would plug into your calculator is divided by 100, or 1 over 100. And so the result you get on the left side is 0.8, and that x is still there. Just a numerical result on the right side. And so literally what we have is that 0.8x is 400, or equals 400. Now we can solve for x, again with the help of the calculator. I do think it's worth writing it down, just so you keep track of why you're dividing 400 by 0.8 instead of multiplying it, let's say. Okay, easy to get turned around there. And you get x is equal to 500. For a complicated problem like this, I think it is worth using your calculator to double check and go back to the original words to plug in. Okay, so here we've gone back to 40% or 0.4 of 2000%, and we're saying of 500% of 10. Okay, we're kind of plugging in the result that we got. And we've put all those in decimal terms. This is 40%, 2000%, 500% of 10. And we do, in fact, get 400, which matches what we know it needed to match. So that's it for calculator or no calculator. We've seen some examples today of questions where you kind of really need the calculator. I certainly wouldn't want to do this question without it. There's just too many terms, too many decimal placement issues. But we've seen some other problems where the calculator really is more trouble than it's worth. So always look at problems both ways. I think it's worth practicing problems both with the calculator and without. You'll form your own preferences for when to use it and when you don't need to. Again, you're more a flexible test taker if you can go either way.